So hi, here we start with the second WindTalk coordinated by the Basque Energy Cluster that are taking place in this Wind Europe Bilbao conference, and where we have the chance to hear insights from experts from the sector in some of the trending topics that are nowadays. This first day we are focusing on life extension and repowering, and particularly we would like to focus more on life extension in the case of this chat, and on smart life cycle management. For this matter, I'm here with three experts from three Basque companies, with Oyer Peñagaricano, CEO of Alerion Tech, which is a small but quickly growing company with drone and data analysis technology, with Pedro Muñoz, Technical Director of Aeroblade, another of our key companies in life extension services, and with Javier Góngora from Siemens Gamesa, Platform Manager at Siemens Gamesa Renewable Energies. Regarding the chat, I'd like to start with the basics. My first question would be, why is so important life extension services for the assets? So, Pedro?
Okay. Well, because everyone owning an asset as a wind farm wants to know what's the real condition of this asset, and how close in every moment this asset is from its original life, or if there's more life that could be used, and extend the profitability period of this investment.
Okay. So Javier, from the turbine manufacturer point of view?
Yeah, in the same way as Pedro was stating, basically once the wind turbine is paid off, it should be interesting for the customer either to think on the repowering or on the lifetime extension. Okay. However, we need to consider that whenever you perform whenever you prorogue the lifetime which is envisioned for the wind turbine, you need to take into account that if you keep operating without any program or without planning what to do, the operative expenses might increase a lot. So you might have a preliminary study based on the analytics and based on the inspections and all the data available from the fleet in order to determine which is the best moment to invest.
Okay, we talk a lot about life extension, but what are other life cycle management options?
Well, I keep on, if you don't mind, Pedro. Basically, the other option, as we were mentioning, is repowering. Depending on grid codes requirements, law on each county or on each country, and some other facts, it might be more interesting to opt by one way or the other, repowering or lifetime extension. But it should be a study case by case, on a case by case basis.
Which is the general trend nowadays? It's more life extension, more repowering?
It depends a lot on the legislation, because depending on grid codes requirements and some other aspects such as grants, and so it's very variable depending on some regions or on others. I have quite more experience on lifetime extension rather than repowering, but I know that repowering is being done in some other areas.
Okay, and how can it affect the inspection and the O&M strategy? How can it affect to the smart life cycle management decisions?
Heavily, in general, yes, because the continuing operation of the wind turbine assets needs to be based on the real condition of the structures, of the equipments, as compared to the original specification or certification loads or initial condition when they started their service life. So what they have done or failed to do in the course of the current moment of life of the wind asset, well, will help or not to provide that good picture that is needed in order to continue the operation and make the good decisions concerning the life cycle profitability, the business case, the complete business case. So yes, and the better, the best.
But
okay.
But I think that would also depend on the data available, right? Like, you have your SCADA data, you have have your other inspection data, but they're again, and going back to the previous talk, I think drones will play an important role because at the moment you can only get generally visual data, but as they become more and more precise and more powerful, you'll be able to get other data that will definitely help extend the lifetime, or at least have a better model, better understanding of the potential of that wind turbine.
Yes, in line with Oyer, as he was mentioning, opting for a predictive maintenance instead of corrective might be the better option to choose. And also, in order to optimize the operative expenses, we all think that in order to optimize the mean time between inspections, you can opt by fracture mechanics in some mechanical components, but in some others, such as composites in blades, you might opt for this kind of inspection, and maybe with drones, that's a very good way to optimize the...
Because you mentioned it, blades is one of the key components in terms of a smart life cycle management, isn't it?
Yeah, correct. It's one of the main costs, together with foundation, towers, and some large correctives. But blades are one of the key costs. In terms of logistics, is very complex. So optimizing the preventive way, in a preventive way, it's a very good thing to do, and drones might help on that aspect, as I mentioned.
If I may, it's also not only doing that, but also helping an OEM like Siemens Gamesa to have a better, say, digital model, a digital twin of how different blades, how different wind turbines might behave in different geographies, and to be able to learn from all that late data, from all those life extension practices, to design better models in the future, right? So.
And regarding maintenance, understanding of the structure of the blades, we see that other components in the nacelle, have a better accuracy in terms of life prediction. What about composite blades, Pedro?
Well, composite structures design has progressed a long way in the last 20, 30 years. Nowadays, you may have enough design information and knowledge on good design and sizing practices to produce very well performing blade structures. This said, probably the part of the problem that is lacking the most is the knowledge on the real behavior under surface condition of the composite blades. So this knowledge is being gathered by the industry as technology goes on, and it relies pretty much on the characterization of the structures when they are designed and during the certification stages.
Okay.
It depends largely. It depends on the fatigue test you might have done, and that helped in fact to identify the potential areas where fatigue might become a problem, and so integration of this knowledge is what is providing the tools to make long-lasting blades, and the identification of those eventual weak points during certification phase is what will also allow to make a good following of the service of the particular blade. So the thing is that we must design blades capable of sustaining the required fatigue life and capable of being monitored during their life, in a similar manner to what is done with other, for instance, with aircraft structures or with nuclear power stations, where structures are monitored and eventual cracks or defects initiation are followed, monitored, and something is done, some repair or maintenance practice is performed before it becomes a problem.
Okay, you want to say something, Javier? Also?
Yeah, in the line that Pedro already mentioned, it's important to perform full-scale testing before putting the blade in the wind turbine generator. But also, we need to take into account that a part of all that fatigue and all those analyses that we have performed, because we need to perform that, but those are dry tests. You also, once in the wind turbine, you have erosion, you have some other facts that are affecting the wind turbine. So it's important to perform periodical inspections in order to ensure that the structural behavior of the wind turbine and of the blade itself, it's going to be as expected in the full-scale testing.
Sure.
So basically, in that sense, I think that the Alerian experience might be a good option just to check and inspect the blades.
Okay, regarding this, one last question. Do you feel that data-driven predictive maintenance is going to be key for smart life cycle management?
Yes, of course. We do think that. We work not only with analytics and inspections, but also with analytical models, which include all the data that Oyer mentioned before, all the statistical. In Siemens Gamesa, we maintain 56 gigawatts since 20 years ago.
Okay.
So that's a wide database with several data that we have been exploded. And having those data in order to add value to our customers and give reliability and give them a better response, more efficient, I think it's the key within the digitalization in the end. To give a proper response, we have a 24/7 service in order to optimize that answers the 99% of the incidences within the first hour. So I think that the way to go is to prediction and digitalization, and working on the big data and automatization in order to in the end optimize the answer to the customer, which is the key.
Okay, thank you. I think that's been very interesting. It seems like there is a lot of potential for life extension and smart life cycle management, and I thank you, all of you, for being here and sharing your thoughts. Thank you very much.
Thank you.